Okay, so now we're going to practice creating these expressions and equations. Um, and so on this next activity, you're actually going to go through the worksheet with me. I'm going to do the first 4 with you, and then you'll be on your own. So with each of these questions, the first thing you want to do is find the slope of the line. Okay, that's going to be that fraction where you have the vertical distance over the horizontal of that slope triangle. Okay. 2, write the equation of the line. So that's where you're going to take the vertical over the horizontal of one triangle and make it equal. So triangle number 1, and make it equal to vertical over horizontal of triangle number 2. And then the third thing is we're going to determine if the points are on the line. And this is just like the activity we did in lesson 11, where I asked if you thought a specific point would be on the line, and you turned the point into a fraction, and then had to determine if they were equivalent. And so we'll practice that some more too. So let's head over to number 1. So this is the first graph that you should see. So number 1, find the slope of the line. So the first thing you're going to do is, what you're missing here are the triangles. You're not given any triangles. And in the last activity and in the notes, you were given the slope triangles. Well, just because they're not given to you doesn't mean they're not there. Sometimes you'll have to find them yourself. Okay. So what you want to do is you want to find a couple spots where you can create the slope triangle. Okay, you can actually, we're going to do this with one triangle, and you'll see what I mean in just a minute. So we're going to find 2 places where the grid marks cross perfectly. Okay, so the first point I found here was from the origin. I went over 3, up 1, 2, 3, 4, 5, 6, 7. So that's the first ordered pair. And the second ordered pair is 6, 9. You do not have to write, well, you're going to end up writing something in, but I wrote those there just so that you could count the same places that I counted. And then you're going to create your slope triangle. You can have your slope triangle on the underside of the line, or it can go above the line. It's up to you. I'll draw mine underneath. Okay. So the first thing we have to do is find the slope of our line. So to find our slope of the line, this is where we want the vertical distance over the horizontal distance. So in our case, my vertical distance is 2 units. My horizontal distance is 3. Now this is nice because we don't have the same thing happening necessarily that happened in the last one yet. We're going to get to that, but not quite yet. Get these out of the way really quick just so that we can see a little bit better my numbers here. There we go. All right, so on my slope triangle, my vertical distance is 2, horizontal is 3. So you're going to need to find a place on your graph and write slope equals 2 over 3. You need to write that somewhere on the graph. Number 2 says write the equation of the line. Now here's the thing. We can create another slope triangle. I could go create tons more slope triangles. Okay, I could even go through and I could make a larger one just like we had in the lesson examples. And I have my vertical is 4, my horizontal is 6. And so you could at first feel like that would be an acceptable equation, but that's not actually what we're looking for. Oops. So I'm going to show you exactly what is expected for this next part about writing the equation. We are looking for something just like we did in lesson 11, just now, in the last set of notes, where we've got y. If you remember, we had y minus a number over x minus a number, and that equaled our other slope triangle, or our other slope, right? So we had y minus some number over x minus a number would equal 2/3. This is what our equation is going to need to look like. The only thing is we have to figure out what these numbers are supposed to be. Okay. But it's not hard. And we're going to practice a bunch. So in preparation for this equation that we have to write, you're going to take one of your 2 points that you found here, or it can actually be any point where it crosses grid marks. So it could be any of these points that you want. I'm going to take one of the points on my triangle since I know the ordered pair already because I counted them out earlier. So okay, so if we think back to how we handled this on the last lesson, let's think about it the same. So I want to, let's say I want to determine or actually want to create my second fraction. So I'm trying to figure this fraction out. Imagine this orange triangle here. Okay, so if we think of the same process that we did on lesson 11, we start at the origin, and I'm going to travel x units, except I don't really want to start measuring until I'm here. I do not want this section. I'm going to remove that part. Okay, now the difference here is we can actually count the units, but we're not going to. Okay, I know that you can see that I have 6 units in between here. Okay, I know you can tell there's 6, but we're going to pretend that we don't know, just like we did in the last lesson. So I'm going to look at this and say, okay, well, this distance would be x minus these 3 units that I want to get rid of here. So I'm going to imagine that my horizontal distance is x minus 3. Now for my vertical distance, I want to start from the x-axis, and I'm going to go up going to go up y units. And I'm going to subtract this chunk right here. I don't want this. So how many units did I have to get out of here? Well, 1, 2, 3, 4, 5, 6, 7. So this distance here is y minus 7 units. Okay. So that would be number 2. Okay, so number 2, my answer would be y minus 7 over x minus 3 equals 2/3. Now I want to check something for a second, just so you can kind of see how this works. And that's where this are the following points on the line come in. Okay, these points are so far off, you have to trust our mathematical answer in a minute. Okay, I don't want you to have to trust the answer. I want you to actually see that what I'm going to show you actually has some truth behind it. See this point here, 6, 9? We know that point 69 is on the line. We see it right here. I know for sure it's on the line. I know this point is on the line. I know this point is on the line. I know this point is on the line. So I'm going to test my equation with one of those, just so that you can see right now that what I created here, I didn't just like pull out of the air. Okay, so here's what we're going to do. To test if a point is on the line, I'm going to take the x value and substitute, and the y value and substitute. And you don't have to copy this part down. Everything else needs to get copied. You can just watch this part. So what I'm going to do is I'm going to replace this x with a 6 and the y with the 9. Okay, so instead of y minus 7, I'm going to say 9 minus 7. And instead of x minus 3, I'm going to say 6 minus 3. 9 minus 7 is 2. 6 minus 3 is 3. That equals 2/3, which means my equation is correct. My equation is going to work. So this is a really good way for you to check your equation. You should know if your equation is right every single time, because you can check it with a point that you know for sure is on your line. And knowing that my equation worked, I'm going to test out A and B. Okay, so for A, instead of the y, I'm going to put a 19. And you should have room on your worksheet. So to the right of A, I want you to put down what I put down here. So 19 minus 7 over 21 minus 3. I am just substituting for the y and for the x. And if the fraction I get is equivalent to 2/3, then I know the point is on the line. So when I subtract, I get 12 over 18. Well, if I divide each of these by 6, I get 2/3. So yes, 2119 would be on the line. Okay, now for B. Again, I'm just going to replace my x with 33 and my y with 28. And I get 21 over 30. Now I can divide each of these by 3. I get 7/10. 7/10 does not equal 2/3. So that's a no. we're going to do number 2. We're just going to jump right in. So find the slope of the line. So the first thing we do is we're going to locate 2 points where my line crosses grid marks. We're going to draw our triangle. Now, one thing that you're going to want to check, oops, it's horrible. Because sometimes the graphs look kind of small, when you get your distance here, like 2 and 1, 2, 3, 4, 5, when you create your triangle and you measure your vertical and horizontal distance, double check that it works again. So there's 2, 2 by 5. So if it works, if that same pattern works the second time, then you know you found the right points. Okay, because some of these, it can kind of play tricks on your eyes. So whatever you get for your slope triangle, you might want to test a second one to make sure that that pattern still works. So my slope of my line is the vertical distance over the horizontal distance. Right? Okay, number 2. For 2, we're going to write our equation. Okay, so this is where I'm going to get y minus something over x minus something has to equal 5 over 2. Remember, this little section over here is basically letting me create a rule or like a general pattern for any slope triangle I could create. Okay, so that's all we're doing on the left-hand side is I'm saying, all right, no matter what triangle you create, this fraction on the left is going to be able to work for whatever points you pick. Okay. All right, and all we're going to do is we're going to start at the origin. And I can even use the triangle I have here. Even though I totally know the distance, I know it's 2. I know it. But we're going to pretend that we don't. Okay, so from the origin, I have to say, okay, well, to get over here, I would have to travel X units, but I only want my measurement to be between these 2 lines. So I'm going to travel X units, but I'm going to subtract this section right here. And that's 2 units I'm going to subtract out. So this distance is actually X minus 2. Now for my vertical, and my vertical is Y units, but I only want this chunk. This is all I want right here. So I went up Y units, but I need to take out this whole chunk. So I'm going to take out 1 unit, 2 units, 3, 4, 5, 6, 7, 8. Okay. Now I want to pause for a second, and I want to look at the ordered pairs really quick, just because there are some patterns that I want you to see. Let's look at the ordered pairs of my triangle just for a second. Before, okay, just in case you're dying to write that down. We get y minus 8, x minus 2. Let's look at the ordered pairs. So this first point here is 2, 1, 2, 3, 4, 5, 6, 7, 8. This ordered pair is 2, 8. This ordered pair up here is 4. So I go over 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And if you really want to get crazy, we can mark this one as 4, 8. All right. Now, what you might notice is if we look at this distance here, we have x minus 2, right? So I have my x value minus the 2 units I already traveled. It's kind of interesting. Okay, if we look at y minus 8, I have my y value minus the 8 here that I already moved up. So from the ordered pairs, you could get those values. Okay, you could get the values from those ordered pairs, or you can think it through, work it out the way I did here too. Okay. I just wanted to give you a little side note there. So again, if you want, you could test an ordered pair. So you could take 2 8s or 2 8 and substitute the 2 and the 8 and see that it could equal, or that would actually not turn out right. You would want to use this one. So you could try the 4 13, and you would see that if you substituted the x with a 4 and the y with a 13, you would actually end up with 5 over 2. Okay, but they actually give us ordered pairs to try. So that's what we're going to use. So for A, we're going to use, this is our equation. Oops. This is number 2. Okay. So for are the points on the line, I'm going to take this equation and I'm just going to substitute the x with a 12 and the y with a 34. And if the fraction ends up being equivalent to 5 over 2, it's on the line. Okay, so 34 minus 8 over 12 minus 2. Well, 34 minus 8 is 26. 12 minus 2 is 10. If I simplify this down, I get 13 over 5, which does not equal 5 over 2, so this is a no. For B, again, I'm going to substitute 20 for the x and 53 for the y. 53 minus 8 over 20 minus 2. Okay, 53 minus 8 is 45. Use a calculator if you need one. 20 minus 2 is 18. Now, it might be kind of hard to see, well, geez, how, I don't even know what numbers they have in common. Think about it like this. I need to see if this equals 5 over 2, right? That's my goal. If I can make this fraction equal 5 over 2, then I know it's on the line. So think about, what do I need to do to 18 to make it equal 2? Well, 18 divided by 9 is 2. Well, 45 divided by 9 actually equals 5. Yes, those are equivalent. So B is a point on the line. Now, when we started the lesson 11 unit, you were able to take the ordered pair and just make the ordered pair into a fraction and see if that fraction was equivalent. And that's not working the same here. And there's a reason for that, but that reason will come later. Okay, so I don't want anybody to feel like I forgot that you made the ordered pairs into fractions at the beginning of lesson 11. We're going to get back to why that worked then and is not working now. We'll get to that in the next unit. Just a little side note. All right, number 3. So for number 3, same thing. Start with the slope of the line. Vertical over horizontal. Okay, so there are my 2 points I'm picking. I'm going to do a triangle on the upper side this time, just so you can see that it works no matter what. So my vertical distance is 4, my horizontal distance is 1. So slope equals 4 over 1. Make sure you're writing this whole thing out. Slope equals 4 over 1. That'll help create the muscle memory of slope in your head. Okay, so that was number 1. Number 2, write an equation of the line. So that's where I'm going to get y minus something over x minus something equals 4 over 1. We just have to figure out what these somethings are going to be. So we can use the distance we're already given here. We can go pick another triangle. We have options, but let's go ahead and figure it out the way we have been. Oops. So if I look at my horizontal or my vertical distance, sorry, that's really, really not straight. Let me actually get a line because this is not working very nicely for me here. Okay, there we go. So for my vertical distance, we'll start with the vertical just because where my triangle is. We don't have to start this way, but it's always nice to kind of mix it up and see that you can do things a little differently too. So my my vertical distance we'll call y, because it's the height, right? It goes up to this point y. I don't know what that is. Let's pretend. But I only actually want this distance. So even though my whole vertical distance is y, I only want this part. So I'm going to take the distance y minus this whole section here. So it's like I'm erasing this part of my distance. So I have y minus 1, 2, 3. So I'm just subtracting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's y minus 10 units. Okay. Oops. So these are the 10 that I just got rid of. Right now for my horizontal, okay. Or you know what, let's do it like this. Look at my horizontal from the top here. Just because we're, oh my goodness. Sorry guys, I'm like aiming sideways, so it's messing all this up. Okay, let's try this. So much better. Okay, so let's look at this distance here. My distance from the y-axis is this far. The only thing is I only want this distance, which I know you can tell is 1, but we're pretending now that we don't know our distances. We don't know the measurements. What I do know is that this distance down here is x, because that's how far I have to travel horizontally. But it's x minus this chunk right here. I don't want that. That's 2 units I just erased. Okay, so again, it's x minus those 2 units that I just erased there. And that gets me this piece. Okay. So you can use that slope triangle that you created to help you get that second equation. Okay. The only thing that I want to add on this one is that you actually have options with your equation. Okay, and I'm going to show you what I mean. Okay. All right, I'm going to erase this for a second. Okay, so here's what I mean about you have options. I'm going to pick a different slope triangle. Okay. So let's pretend this is the slope triangle that you want to use to get your equation. Well, I still know it's going to be y minus something over x minus something, and it's going to equal 4 over 1. That's not going to change because my slope will always be 4 over 1. And I'm always going to have a vertical distance and a horizontal distance, okay? But we're just going to use a different triangle this time. So if I look at my horizontal distance, and I'm not going from the bottom just because it's kind of far away. So if I just look here at my horizontal distance, I know this is 1. Okay, but bear with me here. This distance is x, except the part of the triangle that I want is just this part right here. This is the only piece I want right here. I do not want that part. So I'm going to remove that. So if I have x, I'm going to remove this 1 unit. See, this 1 unit right here is gone. That leaves me with x minus 1. Okay, now let's look at our vertical. Get all this out of the way. For my vertical, okay, the vertical is y, right? But I only want this piece up here. This is all I want, this height, this distance. So I need to get rid of this whole section here. I want that gone. Okay, so I have my y as my vertical distance minus 1 unit, 2 units, 3, 4, 5, 6. So I'm going to take my y distance and take out these 6 units. Okay, now you don't have to get 2 equations. I just want you to just stick with me, and I want you to see something interesting that happens, okay? So for number 3, this is still number 1 here. And this can still be number 2. Okay, so now we're going to check this part. Using the equation, we're going to substitute the x and the y. 30 minus 10 over 7 minus 2. I get 20 over 5. Simplifies down to 4 over 1. That equals my slope. So this is a yes. Let's look at B. 42 minus 10 over 10 minus 2. 42 minus 10 is 32. 10 minus 2 is 8. If I divide each by 8, I get 4 over 1, which equals 4 over 1. Yes, it's true. So both of those points are on the line. Now here's where I want to pause for a second. We're going to test out this equation. Okay, we're going to test A out here just to see what happens, just for fun. Okay, because I know that A is on the line. So it should actually work in this equation too. Let's see what happens. So instead of the y, I'm going to say 30 minus 6 over 7 minus 1. I get 24 over 6, 4 over 1. It does work. So I don't want you getting stuck feeling like you have to use the slope triangle you picked, and that's the only way that you can get the correct equation. You could pick a completely different slope triangle than I picked. There isn't only one option available. I'm just showing you one of the options. Okay, so what you're going to do now is for number 4, you're going to try it on your own. So hit pause, try number 4, and then you're going to come back and see how you did. So hit pause and come back and check out if you're correct. Okay. So you should have gotten slope equals 1/2. Now you could have picked a different slope triangle than me, but whatever slope you got should be equivalent to 1/2. Doesn't have to be the numbers 1 over 2. You could have 2 over 4, 3 over 6, but whatever slope you have should be equivalent to 1 over 2. All right, now hit pause and see if you can come up with an equation of your line. Okay, now depending on your slope triangle, you may have a different equation than me, and that's okay. We're going to test it out in just a second. But your process, you would have y minus a number and x minus a number. To find the number I'm subtracting from y, I got my vertical distance and I took out this extra distance, which was 15. So my vertical was y minus this 15 here. For my x, this was my x distance minus these 6 units that I don't need. That's where I get x minus 6, y minus 15. Now again, you may have something different. Here's where we're going to check. Okay, so for our last bit here, we'll do this part together. With whatever equation you got, you're going to substitute your x and your y and see what happens. So I get 18 minus 15 over 12 minus 6, which gives me 3 over 2. I'm sorry, not 3 over 2. I'm like, hold on, that doesn't look right. 3 over 6, which equals 1/2, which is exactly what I want. So A is yes. Now, if you have a different equation than me, when you substituted and you put the 18 for y and 12 for x, you should have also gotten a fraction that simplifies to 1/2 or whatever your slope is, which should be equivalent to 1/2. Now for B, same thing. Now I'm going to substitute a 24 for y and an 18 for x. And we're going to get 9 over 12. And if I simplify, I get 3 over 4, which is not equal to 1/2. So this would be a no. You should also get a no on number 4. And that's what makes this kind of tricky, is that there's no way to say there's only one answer. Okay. Even with the slope, you could have 2 over 4. It's not 1 over 2, but it's equivalent to 1 over 2. So you wouldn't be wrong if you had slope 2/4. So this isn't something where it's like an easy check. Sometimes if you have different numbers, we have to check and see if they're equivalent. If you have a different equation, you have to be able to decide, when you substitute, are we going to still have a number that equals your slope? Okay, so now your job is going to be to finish this worksheet. And that's it.